Where are you right now? Scrolling through your feed at 2 a.m? Taking a break from work? Maybe you're cooking dinner, or just letting your mind wander while the world buzzes around you. Perfect. You're in exactly the right place. Go ahead and settle in, because tonight we're stepping away from the noise of notifications and deadlines and walking back into a world that moved at the speed of breath and footsteps. A world where survival wasn't about climbing corporate ladders or chasing likes, but about reading the wind, tracking shadows, and understanding the ancient dance between predator and prey. This is Sleepless Homo Sapien, where we tell the stories that shaped us, slowly, carefully, with the kind of attention our ancestors would recognise. If you're here for quick answers and flashy graphics, you might want to keep scrolling. But if you're curious about the long, patient story of how we became human, how we learned to hunt, not just animals but survival itself, then you found your people. And if this kind of deep, unhurried storytelling helps you think, sleep, or just breathe a little easier, a like and subscribe genuinely helps more minds discover this quiet corner of the internet. No algorithm panic, no desperate pleas, just a simple way to keep these stories alive. Now, let's begin. Picture this. It's roughly 400,000 years ago, and you're standing on the edge of what will someday be called Germany. But there are no borders here, no cities, no roads cutting through the landscape, just endless forest, broken by clearings where massive creatures move like living mountains. The air smells of pine resin, and something else, something that makes your pulse quicken. Fresh blood on the wind. You're not alone. Around you, a small band of early humans crouches in the undergrowth, their eyes locked on a scene that would terrify any modern person. 50 meters away, a herd of wild horses grazes in a marshy clearing. These aren't the horses you know from movies, sleek and domesticated. These are stocky, powerful animals with thick necks and alert ears, each one capable of crushing a human skull with a single kick. And yet, your companions are not afraid. They're calculating. This is Schöningen, and what happened here would rewrite everything we thought we knew about early human hunters. For decades, the story we told about our ancestors was simple, almost embarrassing. Early humans were scavengers, we said, cowards who waited for the real predators to finish their meals, then crept in to steal the scraps. They were portrayed as bumbling creatures with crude stone tools, more ape than human, surviving on luck and leftovers. The idea that they could actively hunt large, dangerous animals seemed impossible. Too sophisticated, too organised, too human. But then archaeologists began digging at Schöningen, and the earth started telling a different story. Buried in ancient lake sediments, preserved in conditions so perfect they seemed almost deliberate, lay 8 wooden spears. Not rough sticks sharpened with rocks, but carefully crafted hunting weapons, each one over 2 meters long, balanced like modern javelins, shaped from spruce wood chosen for its strength and flexibility. The tips were fire-hardened to deadly points. The weight distribution was precisely calculated. These weren't the tools of desperate scavengers. These were the weapons of apex predators, and scattered around those spears, the butchered remains of horses, lots of them, ribs cracked open for marrow, shoulder blades marked with cut lines, vertebrae split with systematic precision. This wasn't opportunistic scavenging. This was organised, coordinated hunting on a scale that forced us to completely reimagine what early humans were capable of. But here's where the story gets really interesting. Because those spears at Schöningen weren't just advanced tools, they were time machines. Carbon dating placed them at 400,000 years old, making them the oldest hunting weapons ever discovered. That means our ancestors were crafting sophisticated projectile weapons before they had learned to control fire consistently, before they developed complex language, before they looked anything like modern humans. In fact, the people who made these spears might not have even been our direct ancestors. They could have been Homo heidelbergensis, a species that branched off from our lineage hundreds of thousands of years ago. Think about what that means. The drive to hunt, to organise, to create weapons that extended the power of the human body, that was so fundamental to our nature that multiple human species developed it independently. It wasn't just Homo sapiens who became what it meant to be human at all. Now, you might be wondering how hunters. It was something deeper, something that defined we know these spears were actually used for hunting and not just found near some animals that died naturally. That's where the detective work gets fascinating. When archaeologists examined the horse bones under microscopes, they found something remarkable. Cut marks, hundreds of them. But not random slashes, these were systematic, purposeful cuts in exactly the places you'd expect if someone knew how to efficiently butcher a large animal. The shoulder blades showed evidence of meat removal. The long bones were cracked open to access the nutrient-rich marrow inside. The vertebrae were split to extract the fat and protein from the spinal cord. This wasn't random damage from scavengers or natural decay. This was the work of beings who understood anatomy, who had developed techniques for processing massive carcasses, who knew exactly which parts of an animal contained the most valuable nutrition. But perhaps most telling of all, the pattern of cut marks suggested that these early humans were selective about which animals they targeted. The horse remains at Schöningen weren't from sick or elderly animals that would have been easy prey. They were from healthy adults in their prime, powerful creatures that would have required incredible skill and coordination to bring down. This completely shattered the old narrative. These weren't desperate scavengers picking at leftovers. These were strategic hunters capable of taking down some of the most dangerous prey animals of their time. And this raises a question that archaeologists are still grappling with today. How did they do it? How did a species with brains roughly 2/3 the size of modern humans, using nothing but wooden spears and stone tools, manage to successfully hunt animals that could easily kill them? The answer lies not in individual prowess, but in something far more sophisticated, something that would become the defining characteristic of human success for the next 400,000 years. Cooperation. The horses at Schöningen weren't killed by lone hunters. The evidence suggests coordinated group attacks, probably involving multiple strategies. Some researchers believe these early humans may have used fire to drive animals into marshy areas where their mobility would be limited. Others point to evidence of what might have been pit traps or natural bottlenecks that could be used to isolate individual animals from the herd. But whatever specific tactics they used, one thing is clear. Success required communication, planning, and trust. Each hunter had to know their role. Someone had to spot the prey, someone had to coordinate the approach, someone had to deliver the killing blow, and everyone had to work together to process the meat before it spoiled or attracted competing predators. This wasn't instinct, this was culture, knowledge that had to be learned, practiced, and passed down from one generation to the next. And that knowledge was being transmitted not through genes, but through teaching, through demonstration, through the patient process of showing a young hunter how to grip a spear, how to read animal tracks, how to move silently through underbrush. In other words, these early humans were doing something no other species had ever done before. They were accumulating knowledge across generations, building on the discoveries of their ancestors, slowly but steadily becoming more effective predators, not through evolution, but through education. And the evidence for this cultural transmission is written in the tools themselves. Because when archaeologists compared the Schöningen spears to other wooden weapons found across Europe and Africa, they discovered something remarkable. Despite being separated by thousands of miles and tens of thousands of years, these weapons showed consistent design principles. The same attention to balance, the same fire-hardening techniques, the same understanding of how to select and shape wood for maximum effectiveness. This wasn't coincidence. This was tradition. Knowledge being passed from teacher to student, parent to child, group to group, slowly spreading across continents as human populations migrated and mingled. For the first time in Earth's history, a species was becoming more dangerous, not because their bodies were evolving, but because their minds were learning. But here's what makes this story even more extraordinary. The hunting cultures that emerged from these early experiments didn't just survive, they thrived. Sites across Europe, Africa, and Asia show evidence of increasingly sophisticated hunting strategies developing over the next several 100,000 years. Spears became more refined, hunting tactics became more complex, social organizations became more intricate. By 200,000 years ago, early humans were tracking migrating herds across vast distances, coordinating multi-generational hunting expeditions, and developing specialized roles within hunting parties. Some individuals became expert trackers, others master weapon makers, still others skilled at processing meat and hides. The simple cooperation that began at places like Schoningen had evolved into complex societies built around the shared pursuit of prey. And that transformation didn't happen overnight. It took hundreds of thousands of years of trial and error, success and failure, innovation and tradition. Generations of hunters learning from their mistakes, perfecting their techniques, passing their knowledge to their children. It was slow, patient work, the kind of deep cultural evolution that can only be appreciated when you step back and look at the long arc of human development. But we're just beginning to understand how profound that transformation really was. Because the hunters of Schoningen weren't just learning to kill animals more efficiently. They were learning something far more important. They were learning how to be human. The kill was never the end of the hunt. It was barely the beginning. Imagine standing over the massive carcass of a horse, steam still rising from its body in the cold morning air. Your spear is lodged deep between its ribs, and around you, your hunting companions are catching their breath after what might have been hours of careful stalking and coordinated attack. The animal is down, but now comes the real test of human ingenuity. What do you do with 300 kilograms of meat, hide, bone, and organs when you have no refrigeration, no storage containers, no way to preserve any of it except through knowledge that exists only in your head? This is where the story of early human hunters becomes less about the dramatic moment of the kill and more about something far more sophisticated, the systematic transformation of a dead animal into everything a small band of humans needed to survive. Food, tools, clothing, shelter materials, even spiritual meaning. At Boxgrove, another nothing was wasted, because waste was death. Remarkable archaeological site in what is now southern England, researchers discovered something that completely changed how we understand these ancient processing techniques. Dating back roughly 500,000 years, they found not just animal remains, but the complete operational sequence of how early humans turned prey into survival. The horse shoulder blade tells the story perfectly. Under microscopic examination, it reveals a pattern of cut marks that reads like a manual for efficient butchery. First, shallow cuts around the joints to understand the anatomy, then deeper incisions to separate major muscle groups. Finally, precise cuts to remove tendons and access the richest deposits of fat and protein. Each mark was purposeful, economical, expert. But here's what makes this even more remarkable. The cut patterns at Boxgrove match similar patterns found at sites across Africa, Europe, and Asia, spanning hundreds of thousands of years. These weren't random techniques developed independently by different groups. They were standardized methods being passed down and spread across continents. Early humans had developed not just hunting strategies, but teaching systems sophisticated enough to preserve and transmit complex technical knowledge across vast distances and time periods. Think about what that actually means. About what? A young hunter in what is now Spain was learning the same butchery techniques being used by their contemporaries in Eastern Africa. Not because they had any contact with each other, but because both groups had inherited knowledge from common ancestors who had perfected these methods through countless generations of trial and error. This standardization wasn't accidental. It was the result of something unprecedented in the history of life on Earth. Humans were developing culture that was stronger than genetics, knowledge systems that could evolve faster than bodies, teaching methods that could spread innovations across populations in decades rather than millennia. And that cultural evolution was accelerating. By 300,000 years ago, archaeological sites show evidence of hunting techniques. So sophisticated, they seem almost modern. At Bilzingsleben in Germany, researchers found evidence of organized hunting camps with designated areas for tool production, meat processing, and hide preparation. Different zones for different activities, suggesting not just coordination, but specialization. Some individuals were becoming expert weapon makers, spending their time perfecting spear points and developing new tools. Others focused on tracking and animal behavior, becoming living libraries of knowledge about prey movements and habitat preferences. Still others specialized in processing techniques, learning the intricate skills needed to turn raw carcasses into everything from clothing to containers to construction materials. This specialization created something that had never existed before in the natural world: interdependence based not on genetic relationships, but on shared knowledge and mutual benefit. A master tracker might not be the strongest hunter, but their skills made the entire group more successful. A gifted toolmaker might not be the fastest runner, but their weapons gave everyone a better chance of survival. Success was becoming collective rather than individual. But perhaps the most extraordinary development was happening in the realm of planning and foresight. Because successful hunting required thinking not just about the immediate kill, but about consequences that might unfold over days, weeks, even months. At Terre Amata in southern France, archaeologists found evidence of seasonal hunting camps that were reoccupied year after year for thousands of years. The same locations used by generation after generation of hunters who understood that certain animals would migrate through specific corridors at predictable times. This wasn't opportunistic hunting. This was strategic positioning based on deep knowledge of animal behavior patterns and environmental cycles. The implications are staggering. These early humans were making decisions in spring about where they would hunt in autumn. They were caching tools and materials at strategic locations, planning logistics for expeditions that wouldn't happen for months. They were thinking across timescales that required not just individual memory, but cultural memory, stories and knowledge passed down through generations about the rhythms of the natural world. And they were doing all of this without writing, without permanent settlements, without any of the organizational tools we associate with complex planning. Their planning system was entirely cognitive and social, based on shared mental maps of territory, prey, and seasonal cycles that existed only in the collective memory of the group. This kind of forward thinking required something else that was new in the history of life: abstract reasoning, the ability to imagine scenarios that didn't yet exist, to plan for contingencies that might never occur, to make present sacrifices for future benefits that weren't guaranteed. Modern cognitive scientists call this temporal displacement, the ability to mentally travel forward and backward in time. It's one of the defining characteristics of human intelligence, and archaeological evidence suggests it was already well developed in our ancestors hundreds of thousands of years ago. But temporal displacement wasn't just an individual cognitive ability, it was becoming a cultural technology, a shared way of thinking that allowed entire groups to coordinate their behavior across time and space. When a hunting party set out from their base camp, they weren't just thinking about finding prey, they were thinking about how long they could stay away, what they would need to bring back, how the meat would be distributed, what tools would need to be repaired or replaced, how the success or failure of this hunt would affect future expeditions. Every hunting trip was simultaneously a practical expedition and a learning experiment, generating new knowledge about animal behavior, environmental conditions, and group dynamics that would inform future decisions. Success wasn't just measured in meat obtained, but in wisdom gained. And that wisdom was being preserved in the most sophisticated information storage system ever developed. Human memory, not individual memory, which is fragile and dies with the person, but collective memory, stories and songs and demonstrations that could survive indefinitely as long as there were people to remember them. The hunting grounds of early humans were becoming libraries, landscapes encoded with information about where to find prey, when to expect migrations, how to read weather patterns, which plants could heal wounds and which could poison enemies. Every rock formation, every water source, every game trail was part of a vast information network that existed entirely in the minds of the hunters who travelled through it. But this system had a vulnerability. It was only as reliable as the people who carried it. Lose too many experienced hunters to accident or disease, and generations of accumulated knowledge could vanish overnight. This created enormous pressure to develop better teaching methods, more reliable ways of passing crucial information from older hunters to younger ones. And that pressure was about to drive another revolutionary development in human culture. Something that would transform not just how we hunted, but how we thought, how we communicated, and ultimately how we understood ourselves and our place in the world. Because the greatest prey our ancestors ever learned to hunt wasn't an animal at all. It was knowledge itself. The hunt had taught them to think in ways no creature had ever thought before, but thinking alone wasn't enough. Knowledge trapped in a single mind dies with that mind. The real breakthrough came when early humans learned to do something that seems almost magical when you really consider it. They learned to put thoughts into sounds and sounds into minds that had never experienced those thoughts before. Language wasn't invented in a moment of inspiration. It emerged slowly, painfully, over hundreds of thousands of years from the practical demands of coordinated hunting. When you're tracking a wounded mammoth through thick forest and you need to communicate silently with hunters you can't see, grunts and gestures aren't enough. You need precision. You need nuance. You need the ability to convey not just danger, but wounded bull mammoth, limping on left front leg, moving northeast toward the river crossing, probably 300 meters ahead. The earliest evidence of this linguistic evolution is written in the archaeological record, but you have to know how to read it. At Chasem Cave in Israel, dating back nearly 400,000 years, researchers found something extraordinary. Fire hearths arranged in specific patterns around tool-making areas, with clear sightlines between workstations, and evidence of coordinated activities happening simultaneously in different parts of the cave. This wasn't random. Someone was organising complex, multi-step processes that required constant communication between different groups of people working on different tasks. The tool makers needed to know what the hunters had learned about their prey's behaviour. The hunters needed to understand what new weapon designs were possible. The fire tenders needed to coordinate with the meat processors to ensure optimal cooking temperatures and timing. All of this required a communication system sophisticated enough to convey not just immediate needs, but abstract concepts, plans, possibilities, cause and effect relationships. The kind of information that can only be transmitted through true language. But here's where the story becomes almost surreal in its implications. Because as language evolved to serve the needs of hunting, it began to change how early humans thought about everything else. Words weren't just labels for things that already existed. They were tools for creating new categories of thought, new ways of organising reality, new possibilities that had never existed before. Consider what happened when early humans developed words for yesterday and tomorrow. Suddenly they could think about time not just as an immediate experience, but as a dimension that could be navigated, planned for, learned from. The successful hunt that happened last week could be analysed, its lessons extracted and applied to future expeditions. The failed attempt from last month could be dissected to understand what went wrong and how to avoid similar mistakes. Time became a landscape that could be explored through memory and imagination, and that exploration was collaborative. Multiple minds could pool their experiences, compare their memories, develop collective understanding that was far more accurate and comprehensive than any individual perspective. At Arago Cave in southern France, archaeologists found evidence of what might be the earliest known teaching site. Dating back roughly 450,000 years, the cave contains layers upon layers of tool-making debris, but arranged in patterns that suggest systematic instruction rather than random production. Novice attempts at spear points clustered around areas with evidence of expert work, as if students were learning directly from masters. The really remarkable thing is the progression visible in these learning sequences. You can literally see individual students getting better over time, their early clumsy attempts gradually developing into skilled craftsmanship. But more importantly, you can see innovations being transmitted, new techniques developed by one individual spreading to others, then being refined and improved through collective experimentation. This wasn't just skill transmission. This was cultural evolution in fast motion. Ideas competing with other ideas, successful innovations spreading through populations, failed experiments being abandoned or modified. The pace of change was accelerating, not because human brains were evolving faster, but because human culture was developing mechanisms for preserving and improving knowledge across generations. And the driving force behind all of this cultural acceleration was still hunting. Because hunting remained the most cognitively demanding activity these early humans engaged in. It required the longest-term planning, the most complex coordination, the most sophisticated problem-solving. Every other aspect of their culture, from tool-making to language to social organization, was being shaped by the demands of collaborative pursuit of prey. But something else was happening too, something that would prove even more transformative in the long run. As hunting techniques became more sophisticated, they were creating surplus. More meat than could be consumed immediately, more hides than were needed for basic clothing, more bone and antler than could be used for essential tools. At sites like Bilsingsleben, archaeologists found evidence of the first known storage systems. Not just caching of tools for future use, but organised preservation of processed materials. Meat dried and stored for lean periods, hides prepared and kept for seasonal clothing needs, raw materials stockpiled for tool production during times when hunting was impossible due to weather or prey scarcity. Surplus changed everything. For the first time in the history of life on Earth, a species was producing more than it immediately needed to survive, and that surplus created new possibilities, new choices, new forms of social organisation that had never existed before. Some individuals could specialise in activities other than direct food procurement. The most skilled tool makers could spend more time perfecting their craft. The most knowledgeable trackers could focus on studying animal behaviour patterns. The most gifted teachers could dedicate themselves to passing knowledge to the next generation. But surplus also created new problems. How do you decide who gets to eat the stored meat during a famine? Who controls access to the best tools and materials? What happens when one group has accumulated more surplus than another? These weren't just practical questions. They were the fundamental problems of social organisation, and early human societies were developing solutions that would echo through all of subsequent history. Evidence from sites across Africa and Eurasia suggests that surplus was initially managed through complex systems of reciprocity and obligation. You shared your success with others, creating social debts that could be called in during your own times of need. But reciprocity required memory. Who had helped whom, when, and how much? These social calculations were becoming as complex as the ecological knowledge needed for successful hunting. And like hunting knowledge, social knowledge was being encoded in increasingly sophisticated cultural systems. Stories began to serve not just as entertainment or instruction, but as social contracts. Tales that established who belonged to which group, what obligations existed between individuals, how conflicts should be resolved. The same narrative abilities that allowed hunters to plan complex expeditions were being used to construct the social frameworks that held communities together. And those communities were growing. Archaeological evidence suggests that by 200,000 years ago, some human groups were maintaining relationships across territories spanning hundreds of square kilometres. Networks of bands that shared knowledge, materials, and marriage partners. Trade routes that carried not just goods, but ideas across vast distances. The successful hunting strategies developed in one region were spreading to others through these networks. Innovations in tool design, new techniques for tracking and processing prey, better methods for preserving and storing surplus, all flowing through human social networks faster than any previous form of information transmission in the history of life. But the most important thing being transmitted through these networks wasn't technical knowledge or material goods. It was something far more valuable and far more dangerous. It was the idea that human beings were not just another species struggling to survive in a hostile world. They were something new, something that could reshape the world to serve their needs. The evidence for this conceptual shift is subtle but unmistakable. Starting around 300,000 years ago, archaeological sites begin to show signs of deliberate landscape modification. Not just the temporary impacts of hunting and camping, but permanent alterations designed to make environments more suitable for human activities. Forest clearings created and maintained through controlled burning. Water sources modified to improve access and reliability. Game trails altered to funnel prey toward favourable hunting locations. Early humans weren't just adapting to their environments anymore. They were adapting their environments to themselves. This was a line that had never been crossed before in the history of life. Every other species, no matter how successful, ultimately remained subject to the constraints of their environment. Humans were beginning to reverse that relationship, making the environment subject to their will. And that reversal would prove to be the most consequential development in the story of life on Earth. Because once humans learned they could reshape the world around them, there was no limit to how far that reshaping might go. The hunt had taught them to cooperate. Cooperation had led to language. Language had enabled cultural evolution. Cultural evolution had created surplus. And surplus had given them the power to imagine possibilities that transcended the basic requirements of survival. They were no longer just hunting animals. They were hunting the future itself, tracking down visions of what the world could become and making those visions real through the coordinated application of human will and intelligence. But they had no idea where that hunt would ultimately lead them. No conception of the world they were creating with every successful expedition, every innovation passed between generations, every landscape modified to serve their purposes. The greatest predators in the history of Earth were about to become something far more powerful and far more dangerous. They were about to become gardeners of reality itself. The first gardens weren't planted with seeds. They were carved with fire. Picture yourself standing on a hillside in what is now northern Spain, maybe 250,000 years ago. The landscape stretches before you in ways that would seem impossible to modern eyes. Vast forests of oak and pine broken by natural clearings where massive herbivores graze in herds that darken the horizon. But something is different here. Something deliberate. The clearings aren't entirely natural anymore. They're too regular, too well positioned, too convenient for the small groups of humans who have been returning to these same hills for generations. In your hand, you hold a burning branch, not randomly grabbed from a lightning strike, but carefully maintained, fed with dry tinder, carried from camp to camp like a sacred torch. Because fire isn't just a tool anymore, it's becoming a paintbrush, and the entire landscape is your canvas. This is where the story of human hunters takes its most revolutionary turn. Because somewhere in these ancient hills, our ancestors made a discovery that would change everything. They learned that they didn't have to accept the world as they found it. They could edit it. The evidence is subtle at first. At sites like Terra Amata and Bilsingslaben, archaeologists found something puzzling. Charcoal deposits that seemed too extensive, too systematic to be natural forest fires. Chemical analysis revealed burning patterns that followed human occupation sites, spreading outward in deliberate arcs that corresponded to hunting territories and seasonal migration routes. These weren't accidental fires or simple hearth-warming flames. These were controlled burns, carefully planned and executed to reshape entire ecosystems according to human needs. And the sophistication of this landscape management is staggering when you really think about what it required. First, you had to understand fire itself. Not just how to make it, but how it spreads, how different materials burn at different rates, how weather conditions affect combustion, how to create fire breaks to control the burn area. You needed to know which seasons were safe for burning, and which would lead to uncontrollable wildfires that could destroy everything you were trying to create. But understanding fire was only the beginning. You also had to understand ecology at a level that would impress modern environmental scientists, which plants would regenerate quickly after burning and which would be permanently destroyed. How different animals would respond to changed landscapes, which burning patterns would create the kind of habitat that would attract the prey species you wanted to hunt. At Schöningen, where those remarkable 400,000-year-old spears were discovered, researchers found evidence of this ecological engineering on a massive scale. Pollen analysis from the lake sediments shows dramatic shifts in vegetation patterns that align perfectly with periods of human occupation. Dense forests giving way to open woodlands, scrubland being replaced by grasslands, wetland margins being modified to create better access to water and fishing opportunities. This wasn't random environmental change. It was systematic landscape architecture, designed and implemented by people who understood that the world could be improved to serve their purposes. And the improvements were remarkably sophisticated. By burning sections of forest in rotating patterns, early humans created what ecologists now call a mosaic landscape. Patches of different vegetation types at different stages of regeneration, creating diverse habitats that could support a much wider variety of prey species than any single ecosystem type. Young forest growth attracted browsers like deer and elk. Open grasslands supported herds of horses and aurochs. Wetland edges provided habitat for waterfowl and small game. But the real genius was in the timing. These burns weren't random acts of destruction. They were carefully scheduled interventions designed to maximize hunting opportunities across multiple seasons and years. A section burned in spring would produce tender new growth that would attract herbivores in summer. Areas burned in late fall would create winter browse that could sustain prey populations through lean months, ensuring they would still be available for hunting when other food sources were scarce. This required planning on timescales that stretch human cognitive abilities even today. Decisions made in one season about where to burn would determine hunting success years in the future, and those decisions had to be coordinated across entire territories, because a poorly planned burn in one area could affect game movements across hundreds of square kilometres. The social implications are staggering. This level of landscape management could only work if multiple groups were communicating and coordinating their activities across vast distances. Territorial boundaries had to be negotiated. Burning schedules had to be synchronized. Knowledge about ecological relationships had to be shared and preserved across generations. Archaeological evidence suggests that by 200,000 years ago, human groups across Europe and Africa were maintaining these managed landscapes through networks of cooperation that spanned continents. Similar burning patterns appear at sites separated by thousands of kilometres, suggesting shared knowledge and coordinated strategies that were being transmitted through cultural networks faster than genetic evolution could ever achieve. But here's where the story becomes almost unbelievable in its implications. Because the humans who were doing this landscape engineering weren't Homo sapiens, at least not entirely. Many of these managed landscapes were created by Neanderthals, by Homo heidelbergensis, by species that we once thought were too primitive for complex planning and environmental manipulation. This means that the drive to reshape the world wasn't unique to our particular branch of the human family tree. It was something deeper, something that emerged independently in multiple human species as soon as their cognitive abilities crossed some critical threshold. The moment any human population developed the ability to think abstractly about cause and effect relationships across extended time periods, they began trying to engineer their environment to serve their needs. And they were remarkably successful. Isotope analysis of animal bones from managed landscapes shows that prey species were healthier, more numerous, and more predictable in their movements than animals living in purely natural ecosystems. Human landscape management was actually improving the ecological productivity of entire regions, but it was also creating something that had never existed before in the history of life on Earth. Artificial ecosystems that were dependent on continued human intervention to maintain their productivity. Stop the controlled burning, and the carefully managed mosaic of habitats would gradually revert to dense forest that could support far fewer prey animals. Early humans had created their first addiction, not to a substance, but to a way of life that required constant, increasingly sophisticated intervention in natural processes to maintain its benefits. They had learned to improve on nature, but in doing so, they had made themselves indispensable to the improved version. This dependency drove another acceleration in cultural evolution. As managed landscapes became more complex, they required more specialized knowledge to maintain effectively. Some individuals became expert fire managers, developing sophisticated understanding of burning techniques and timing. Others specialized in reading the responses of different prey species to landscape changes. Still others focused on the social coordination required to implement burning programs across multiple territories. The knowledge required to maintain these artificial ecosystems was becoming too complex for any individual to master completely. Success required not just cooperation, but specialization and interdependence on a scale that had never existed before. And that interdependence was creating new forms of social organization, new ways of thinking about identity and belonging, new concepts of collective responsibility that would echo through all of subsequent human history. At the same time, the success of landscape management was creating new challenges. Managed territories were more productive than natural ones, which meant they could support larger human populations. But larger populations required more extensive landscape management to maintain the same standard of living. And more extensive management required even more sophisticated coordination and specialization. It was a feedback loop that drove constant innovation and expansion. Success bred the need for more success. Improvement demanded further improvement. The better humans became at managing their environment, the more dependent they became on their ability to continue improving their management techniques. Archaeological evidence from this period shows exactly this pattern. Sites become larger and more complex over time. Tool technologies become more sophisticated. Evidence of long-distance trade and communication networks becomes more extensive. Social organization becomes more hierarchical and specialized. But perhaps most importantly, the archaeological record begins to show the first clear evidence of something that would become the defining characteristic of human culture: the deliberate modification of objects not for immediate practical use, but to store and transmit information across time and space. Carved bones with regular marking patterns that might represent counting systems or calendars, stone tools with decorative elements that seem to indicate group identity or individual craftsmanship. Ochre pigments prepared and stored for purposes that go beyond simple body painting or hide processing. These aren't just the first stirrings of art and symbolic thinking. They're the first evidence of humans developing external memory systems, ways of encoding important information in objects that could survive longer than individual human lifespans. And the information being stored was largely practical knowledge about landscape management, hunting techniques, and seasonal timing that was becoming too complex to preserve through oral tradition alone. The hunters were becoming librarians, creating the first information storage systems in the history of life on Earth. And those storage systems were about to enable another revolutionary development that would transform not just how humans hunted, but how they understood their relationship to the entire world around them. Because once you learn to store information outside your own memory, you can begin to accumulate knowledge across generations in ways that transcend the limitations of individual human lifespans. You can build on the discoveries of your ancestors, test their ideas against new evidence, develop increasingly sophisticated understanding of complex systems. And the most complex system these early humans were trying to understand was the intricate web of relationships that connected every aspect of their managed landscapes. The connections between fire and vegetation, between vegetation and animal behavior, between animal behavior and hunting success, between hunting success and social organization, between social organization and the ability to plan and implement even more sophisticated landscape management strategies. They were beginning to see the world not as a collection of separate objects and creatures, but as a dynamic system of interconnected relationships that could be understood, predicted, and manipulated through the application of accumulated knowledge and coordinated effort. This systems thinking would prove to be the most powerful cognitive tool humans ever developed. More transformative than language, more revolutionary than tool making, more consequential than any single technological innovation. Because once you understand the world as a system of relationships, rather than a collection of objects, you can begin to imagine changing those relationships to create entirely new kinds of systems. Systems that have never existed before. Systems designed to serve human purposes. Systems that could transform not just landscapes, but the entire trajectory of life on Earth. The hunters had learned to read the world. Now they were about to start writing their own version of it. But writing the world required more than fire and planning. It required something that would challenge every assumption about what it meant to be human. Because around 150,000 years ago, in caves scattered across what we now call the Middle East and North Africa, early humans began doing something that no creature in the history of Earth had ever done before. They started talking to the dead. Not literally, of course, but when archaeologists excavated sites like Kafse Cave in Israel and Eskul on Mount Carmel, they found something that stopped them cold. Bodies, lots of them, but not scattered randomly or abandoned where they fell. These were deliberate burials, carefully arranged, often accompanied by tools, ochre pigments, and sometimes even flowers. Pollen analysis from some graves suggests that mourners may have placed bouquets of wildflowers with their dead. This wasn't disposal of corpses. This was ceremony. This was memory made permanent, and it represented a cognitive leap that was almost as significant as the development of language itself. Think about what burial actually requires as a mental process. First, you have to understand death as something more than just the cessation of movement. You have to grasp that the person who once inhabited that body existed as something separate from the physical form, something that could be honoured, remembered, grieved for even after the body stopped functioning. But more than that, you have to believe that this honouring and remembering matters, that the dead person somehow still exists in a way that makes ceremonial treatment meaningful. You have to develop concepts of identity that transcend physical presence, ideas about continuity that extend beyond immediate sensory experience. This is abstract thinking of the highest order, the kind of cognition that requires not just intelligence, but imagination, the ability to conceive of realities that can't be directly observed or measured. And once early humans developed that ability, they began applying it to everything else in their world. At Shanidar Cave in Iraq, researchers found evidence of Neanderthal burials dating back 60,000 years. One individual, an elderly male who had survived for years despite severe injuries that would have left him unable to hunt or gather food, was buried with what appears to be a carefully selected arrangement of medicinal plants. Someone had cared for this disabled individual throughout his adult life, then honoured him in death with symbols of healing and renewal. This wasn't just compassion, though. That's remarkable enough in itself. This was a sophisticated understanding of individual identity as something that persists beyond physical capability. The value of a person wasn't determined solely by their ability to contribute to immediate survival needs. There was something else, something intangible but crucial, that made each individual worth preserving and remembering. And that recognition was reshaping how humans thought about everything. If individual identity could transcend physical form, then maybe other things could too. Maybe the knowledge gained from successful hunts could exist independently of the hunters who gained it. Maybe the patterns observed in animal behaviour could persist beyond the particular animals that exhibited them. Maybe the relationships between fire and vegetation, between seasons and prey movements, between social cooperation and survival success could be understood as permanent truths, rather than temporary observations. The burial sites become libraries of a different sort, not just repositories of bodies, but collections of ideas about continuity, identity, and meaning that were being tested and refined through the most profound human experience of all, the confrontation with mortality. At Cima de los Huesos in Spain, archaeologists discovered something even more extraordinary. A collection of 28 human bodies, dating back 430,000 years, deliberately deposited in a deep cave shaft, along with a single, beautifully crafted stone hand axe. This wasn't a burial in the traditional sense, because the bodies weren't arranged in individual graves. Instead, they appear to have been placed in the cave over an extended period of time, creating what might be the world's first known cemetery. But here's what makes this discovery so remarkable. The cave shaft was completely inaccessible from the surface. Getting the bodies down there would have required enormous effort, careful planning, and specialised knowledge of cave systems. And the single hand axe found with them wasn't a practical tool. It was made from an exotic red stone that had to be transported from kilometres away, crafted with extraordinary skill, and apparently never used for any practical purpose. This was art. This was ceremony. This was a statement about human identity and continuity that was being made not for the living, but for the dead. Or perhaps more accurately, for the living to contemplate their relationship with the dead, with the past, with the meaning of their own existence. The cognitive implications are staggering. These early humans weren't just planning hunting expeditions across seasons and years. They were thinking about permanence across generations and centuries. They were developing concepts of legacy, of meaning that could outlast individual lifespans, of purposes that transcended immediate survival needs. And they were beginning to apply that kind of thinking to their hunting activities as well. Because if identity and knowledge could persist beyond individual death, then maybe the improvements they were making to landscapes and ecosystems could be designed to persist beyond their own lifetimes too. Archaeological evidence from this period shows exactly that kind of long-term thinking. Landscape management projects that would take decades to reach full productivity. Forest burning patterns designed not just for immediate hunting success, but to create sustainable systems that could support human communities indefinitely. Trade networks established not just for current needs, but as permanent infrastructure that could facilitate knowledge exchange and resource sharing across vast distances and extended time periods. At Blombos Cave in South Africa, researchers found evidence of what might be the earliest known symbolic storage system. Pieces of ochre with engraved geometric patterns dating back 75,000 years. The patterns are too regular to be accidental, too complex to be simple decoration. They appear to be information of some kind, encoded in visual form, preserved in durable materials that could survive long after the people who created them had died. Nobody knows what information these symbols were meant to preserve. Maybe they were maps of hunting territories. Maybe they were calendars tracking seasonal changes. Maybe they were records of successful hunting techniques or social agreements between different groups. But whatever they represented, they demonstrate something unprecedented. Humans were developing external memory systems that could preserve complex information across time periods longer than individual human lifespans. This was the beginning of history in the truest sense, not just the recording of events, but the deliberate preservation of knowledge for future generations. The hunters weren't just accumulating wisdom through their own experiences anymore. They were inheriting wisdom from ancestors they had never met, building on discoveries made by people who had died long before they were born. And that inheritance was accelerating the pace of cultural evolution to speeds that made genetic evolution look glacial by comparison. Innovations that might have taken thousands of years to spread through biological inheritance could now be transmitted across continents in a few generations through cultural networks. Successful hunting strategies developed in one region could be adopted and refined by groups thousands of kilometers away. Landscape management techniques that worked in one environment could be adapted to different climates and ecosystems through systematic experimentation and knowledge sharing. The archaeological record from this period shows evidence of increasingly sophisticated coordination between human groups separated by vast distances. Similar tool technologies appearing simultaneously across multiple continents. Identical burial practices being adopted by populations with no apparent direct contact. Trade goods moving along routes that spanned from Africa to Asia to Europe, carrying not just materials but ideas, techniques, and cultural innovations. But perhaps the most remarkable evidence of this cultural acceleration is found in the tools themselves. Starting around 100,000 years ago, the rate of technological innovation begins to increase exponentially. New spear point designs appearing every few thousand years instead of every few tens of thousands of years. Composite tools that combine multiple materials in increasingly sophisticated ways. Specialized hunting implements designed for specific prey species and hunting conditions. At Pinnacle Point in South Africa, archaeologists found evidence of the earliest known use of heat treatment to improve stone tool quality. By carefully controlling fire temperature and exposure time, early humans learned to alter the molecular structure of certain types of stone, making them easier to shape and sharper when finished. This wasn't accidental discovery. It was systematic experimentation, the application of accumulated knowledge about fire and materials to solve specific technical problems, and the solutions were being shared. Heat treatment techniques developed in southern Africa appear in the archaeological record of the Middle East and Europe within a few thousand years. Knowledge was flowing through human networks faster than human populations were migrating, suggesting active communication and deliberate knowledge transfer between distant groups. The hunters were becoming scientists, developing systematic methods for testing ideas, preserving discoveries, and building on the work of previous generations. But they were also becoming something else, something that would prove even more transformative in the long run. They were becoming storytellers, because as burial practices became more elaborate and symbolic systems became more sophisticated, early humans weren't just preserving practical knowledge about hunting and survival. They were developing narratives about meaning, purpose, and identity that could bind groups together across time and space. Stories about heroic ancestors whose wisdom guided current decisions, tales about the proper relationships between humans and animals, between the living and the dead, between individual desires and collective needs. These stories weren't entertainment, they were technology, social technology that could coordinate the behaviour of hundreds or thousands of individuals without requiring direct personal relationships between all of them. A hunter in Spain could cooperate with a toolmaker in France not because they knew each other personally, but because they shared stories about proper behaviour, mutual obligations, and common purposes that made cooperation feel natural and necessary. The power of shared narrative to coordinate large-scale human cooperation would prove to be the most consequential development in the history of life on Earth. More transformative than fire, more revolutionary than tool-making, more significant than any individual technological innovation. Because once humans learned to use stories to coordinate their behaviour, there was no limit to the scale of cooperation they could achieve. An unlimited cooperation meant unlimited power to reshape the world according to human purposes. The hunters were about to become architects of reality itself, but first they had to learn to hunt the most dangerous prey of all, each other. War wasn't invented, it evolved, and like every other human innovation, it began with a hunt that went wrong. Picture yourself crouched in tall grass beside a waterhole, somewhere in what is now Eastern Africa, maybe 80,000 years ago. Your hunting party has been tracking a herd of antelope for days, following game trails that your people have used for generations. But when you finally reach the watering place where the animals should be drinking, you find something else entirely. Fresh footprints in the mud. Human footprints, but not from your group. Another band has been here recently. They've disturbed the water, scattered the prey, left behind the unmistakable signs of their presence. And as you study their tracks, reading the story written in pressed earth and broken vegetation, you begin to understand something that chills you more than any predator ever could. These strangers are using the same hunting grounds your ancestors have relied on for countless generations. They know the same animal paths, the same seasonal patterns, the same techniques for driving prey toward natural bottlenecks. They hunt exactly like you do, which means they think exactly like you do, and that makes them the most dangerous creatures you've ever encountered. For hundreds of thousands of years, human groups had been spreading across continents, following game migrations and establishing territories in the richest hunting grounds available. As long as the world was vast and populations were small, different bands could coexist without much direct competition. There was always another valley to explore, another river system to settle, another herd to follow when your usual prey moved on. But by 80,000 years ago, the best territories were filling up. The landscape management techniques that had made human hunting so successful were creating a new problem. Improved hunting grounds could support larger populations, but they also attracted more human groups competing for the same resources. And unlike every other species, humans weren't just competing for food. They were competing for knowledge, for territory, for the right to implement their own landscape management strategies in the most productive areas. At Jebel Sahaba in Sudan, archaeologists found evidence of what might be the world's first known battlefield. Dating back roughly 13,000 years, the site contains the remains of 59 individuals who died violent deaths. Men, women and children, their bones bearing clear evidence of projectile wounds from spears and arrows. Many had been struck multiple times, suggesting organised combat rather than isolated murders or accidents. But here's what makes this discovery so haunting. The weapons that killed these people were identical to the ones they carried themselves. The same spear point designs, the same manufacturing techniques, the same materials. This wasn't a clash between different species or even different cultures. This was human versus human, using the same technologies, the same strategies, the same accumulated wisdom of generations of hunters. The prey had learned to hunt itself. The implications ripple backward through time like shockwaves. Because if humans were fighting organised battles 13,000 years ago, the cognitive and social structures that made warfare possible must have been developing for tens of thousands of years before that. You don't suddenly invent military tactics, coordinate group combat, or develop specialised weapons of war without centuries of cultural evolution building toward those capabilities. Archaeological evidence from earlier periods begins to make more sense when viewed through this lens. The elaborate burial practices weren't just about honouring the dead, they were about creating group identity, establishing clear boundaries between us and them that could justify violence against outsiders. The landscape management techniques weren't just about improving hunting success, they were about claiming territory, marking boundaries, creating visible evidence of group ownership that could be defended by force if necessary. The symbolic systems that emerged around 100,000 years ago weren't just abstract art or primitive religion. They were uniforms, markers of group membership that could be recognised at a distance, ways of instantly identifying friend from foe in the split second before a spear was thrown or an arrow released. Even the stories that bound human communities together were becoming weapons. Narratives about heroic ancestors who had defended the tribe's territory against invaders, tales about the sacred nature of certain hunting grounds that justified violence against anyone who violated them. Myths about the superiority of one's own group and the subhuman nature of competing bands. And so the circle closes, from wooden spears carved by firelight to landscapes painted with controlled burns. From the first shared kill to the first shared story, the hunters of prehistory didn't just learn to survive. They learned to dream, to remember, to imagine worlds that had never existed, and then make them real through the coordinated power of human will. These weren't our primitive ancestors stumbling toward civilization. They were us, barefoot and brilliant, already carrying in their minds and hands everything we would ever become. The rest, as they say, is history,